Now this is from exercise 6C. We're starting to get just a little bit more detailed now. So we can see we've got a few more words here, and we're going to have to start interpreting what the question's actually asking. So it says find the equation of the tangent to the curve y equals x squared, which is parallel to y equals x. Now we need to start thinking about what information do we need. Well, if it's a tangent, that means it's a straight line. Therefore, we're going to need to find the slope of that line, and we're also going to need to find a point that it passes through. So to find the slope, we're going to differentiate. So if y equals x squared, then what I can say is dy by dx equals 2x. Now there's also this part here. On previous questions, we were given an x value, so we could substitute in to find the slope. And this time we're not, so we're going to have to interpret why have they given us this piece of information here. Now we know when it says parallel, it means they have the same slope. So we need to know what is the slope of this. So y equals x has a slope of 1. Therefore, the one that's parallel to that will also have the same slope. So the tangent, in other words, will also have a slope of 1. So that's a summary of the information that we need. We need a point and a slope, and it must be parallel to y equals x, so the slope must be 1. Now we also said we can differentiate, so if we differentiate we get 2x, and then we need that slope to be 1. So in other words, 2x equals 1. Now if we go ahead and solve that equation, then what we find is x equals 1/2. So we know the slope, 1. We know an x coordinate, 1/2. What we don't have is a y coordinate, because then we can use the point slope formula. So if we substitute a half back into the original equation, this is supposed to be a squared here. So a half squared equals 1/4, and then we do have a point, 1/2 and 1/4. Once again, we have the slope already. Slope must be 1, and then therefore we can use our point slope formula. So we have everything that we need. Oops. Point slope formula, y minus the y value equals the slope x minus the x value, and then we can go ahead and work out what we need to. I multiplied by 4 here just to show that it does agree with the answer in the back of the book. Now, a similar question, but with a little more detail, still from that same exercise. This is 6C. So find the equation of the tangent to the curve given here, which is perpendicular to the line. So we need a point, we need a slope. Notice they haven't given us the x value again, so we're going to have to try and find that out. So it says perpendicular to this equation here. Now, if this was in slope-intercept form, we could find the slope and then do the negative reciprocal to find out what the perpendicular slope would be. So if we rearrange this, dividing both sides by 2, then you can see from this then, the slope of this is 1/2. Now it says we want the one that's perpendicular to this line though. So if this slope is 1/2, the negative reciprocal for that would be -2. Now that's what we want the slope of the tangent to be. Now I know it's sort of confusing for this one because tangent we don't do the negative reciprocal, but for this part it says it's got to be perpendicular to this information. So that's why we did the negative reciprocal there. So we want to know when the slope of this is going to be -2. So to find the slope of this, we're going to differentiate. So dy by dx, bring the power to the front, decrease the power by 1, 2x. Differential of -2x is just -2. And we want that to equal -2. And then if we solve this equation, we get 2x equals 0. So in other words, x equals 0. Let's just summarize what we have. We have our slope, 1/2. We have an x coordinate, 0. All we need is the y coordinate, so we can use that point slope formula again. So we're going to substitute this back into our original equation, which was here. Y equals x squared minus 2x. So when you plug 0 in here, 0 squared minus 2 times 0 is also going to give you 0. So actually it goes through 0, 0. So it goes through 0, 0, has a slope of -2. Therefore, we can just go ahead and write the equation straight away. Y equals -2x. We can see that it has a y-intercept of 0, so y equals -2x plus 0 would answer that question quite nicely. Or if you prefer, 2x plus y equals 0 in standard form. Once again, this is the same exercise, but we're on question 11 now. Find the equation of the normal. So we know we're going to have to find the slope of the tangent and do the negative reciprocal. Find the equation of the normal, which is parallel to the y-axis. So we've got to think a little bit about what this actually means. So the y-axis is your vertical axis. So anything parallel to that actually has an undefined slope. So that's going to make this question a little interesting. Same manipulation as before though, we need to find a point and we need to find a slope. Now to find the slope, we're going to differentiate. So I just differentiated there. I did FOIL first on this to give us this expression, and then I just differentiated each term. Remember the differential of 1 is 0. So once again, parallel to the y-axis means the slope is undefined. That's what we figured out here. But if the normal is undefined, then that actually means though that the slope of the tangent is 0. And that's what we can actually use to help us find out where this actually occurs. So I want to know when is the slope equal to 0. So this is my equation for slope, and I want to set it equal to 0. And if I solve for that, then I find that x equals 1. Now I can plug 1 back into this formula to find out the y value, and I get y equals 0. Now that's actually not going to help me for this question anyway, because I want to know a slope that has undefined slope, but passes through x equals 1 on the x-axis. And actually that's a straightforward question. That actually is just the equation, x equals 1. Just a reminder on this one, so horizontal lines are just y equals and then the number it passes through on the y-intercept. And vertical lines are of the form x equals, and the number is just simply where it passes through the x-axis. So I didn't actually do that much on this question, but certainly a lot of interpretation on this question. Knowing when to do the negative reciprocal is important, and also dealing with those zero slopes and undefined slopes can be a little tricky as well.